Hello, everyone. My name is Derek, Senior Cloud Technologist at Suse. Just want to extend my warm welcome to all of you who attend this session. This session is about best practices in migrating applications into SUSE container and application platform. Here's today's agenda. First, we'll talk about the motivation for enterprise to move their application into SUSE container and application platform, and what are the key challenges that they are facing with. And then we'll introduce the best practices in migrating these applications into this platform. And followed by it, we'll illustrate the process by showing you a live demonstration about migrating an application. In this demo, we're going to migrate a Java-based application, which is the programming language predominantly used by the existing enterprise today. And lastly, we will show you what are the suggested steps that you can do after you migrated your applications into SUSE Container and Application Platform. Without further ado, let's get started now. First, let's talk about the motivation and challenges. Why do enterprises want to migrate their legacy applications when it's working fine with their existing business? Well, there are mainly four reasons to do it. To stay out from the competition, enterprise needs to deliver innovative digital experience to their customers faster, make it faster. Time to market is important for them, so they can't rely on legacy IT infrastructure, which is slow to make any change to meet the new change in the customers or to respond to their new needs. And secondly is to drive the cost efficiency with the edge technology like containers, which are lightweight without those overheads from virtualization platform. This can make better use of the IT infrastructure, and through also the practice of continuous integration and delivery, the automation also makes the whole cost of rolling out new application features more cost effectively. Scalability is also very important for the enterprise to meet any unexpected demand surge from customers, and flexibility of the IT infrastructure and its application is equally important, so that when the business is required to expand to some new geographical location, that flexibility or portability of the application can make it faster for the enterprise to reach out to new geographic location to capture new business. And lastly, DevOps automation is important to make new digital experience roll out faster by putting the dev team and the op team working together in order to keep up the best customer engagement for the enterprise. So all in all, as you can see here, the whole objective is to move the legacy application into the cloud native way, so that the whole IT infrastructure will be transformed to solve the pain points for the enterprise to grow and to engage their customers at profit with the use of edge technology like container, microservices, and continuous integration delivery practices. So with all these benefits in mind, to fully maximize the value of cloud computing, applications must be transformed from monolithic legacy applications into a cloud-native one. Before the adoption of technologies like containers, microservices, continuous integration, or delivery, one may just lift and shift the app to run on virtual machines from on-prem to public cloud using the IaaS service. While this let the application run on cloud, it doesn't really fully taking the benefits of cloud computing until you further transform the applications to become cloud native, which we will be discussing further down in the presentation. But the app is set to be cloud native. There are 5 attributes that they need to meet. First, it has to be auto-scalable, and it has been designed for failure, and is modularized by breaking it down into microservices, for example, and it should be API driven, fully automatable, and its whole life cycle, it should be automatable as well through the CI/CD process. So in order for the cloud native application to run effectively, it can't be simply run on IaaS platform. Modern platform need to be supporting all these cloud native applications, such as the CaaS platform or the PaaS. SUSE provides container and application platform that leverage the open source de facto container orchestration tools like Kubernetes to host these cloud native applications. What's unique to this solution is that SUSE team brings the Cloud Foundry experience on Kubernetes to boost developer productivity as well. Well, while many enterprises want to tap on the advantage of using Kubernetes and Cloud Foundry, they often face many challenges and concerns in the application migration process. Here is a list that you can see on this slide, and you may want to take a pause to read them, as I'm not going to go through them one by one. But in short, to many enterprises, running cloud native apps on new platforms like Kubernetes and Cloud Foundry is new. This causes the management to have a relatively long list of concerns, including risks involved, training needed, or even rewrite the entire application, which may take forever to do so, and it will be costly. It's hard to estimate how long and how much it costs. So is there any tool that can help enterprises to eliminate these challenges? Or how does the other enterprise do when they successfully transform their legacy application into a cloud native one? Let's take a look. Now, in this session, we're going to talk about the best practices in migrating applications into the container platform. There are many consultants and vendors offer services to help enterprises to modernize enterprise applications. Some even claim to have their own tools, maybe open source or closed sourced, to accelerate such migration process. And yet, we don't see a single winning tool to easily convert all legacy applications in different sizes and shapes into modernized cloud-native applications in a cost-effective and predictable way. But don't be disappointed. It doesn't mean it's a rocket science to modernize your applications. A process-oriented approach can systematically help enterprises to modernize their applications. These steps include, first, inventory, doing an assessment of all your applications that you have, and then you profile them, prioritize them, see which one is more important to go cloud native, to be mission critical, or to be strategic to grow your business. And then once you identify these applications, you may want to identify the strategies. There are different strategies that we are going to cover in the next slide to help you to migrate to the container and application platform. Once your application is moved into that container and application platform, you probably want to set up the metrics to measure its effectiveness, the things that you want to further improve, and then you will want to track the outcomes or the results, how it can help your business. So these are the, in general, the process that we will take. To further elaborate these 5 steps, I have put down a general workflow in this slide. As I mentioned earlier, the first 2 steps, inventory profiling, are basically to build an existing application portfolio. And then we prioritize these apps based on factors like its business value, its importance, technology complexity, and so on. But each enterprise may have different weighting on these factors depending on their business objectives. Prioritizing apps to be migrated is like a cost-benefit analysis exercise, with estimated level of risks involved and its impact. To better estimate the time and effort for migrating each app, which is one of the key challenges as we have seen earlier in the presentation, it's also important to understand the technology these apps are used to build. Once these apps are identified to be migrated, then there are different strategies to port them over to the container and application platform. These are commonly identified as rehost, replatform, or refactor. It depends on the effort that we need to transform the applications to fit into the container and application platform powered by Kubernetes or Cloud Foundry. But for certain apps, you may want to completely rewrite them. It may be costly and lengthy process, but that could be one possible options. Some of them could be replaced by buying the off-the-shelf package maybe to achieve the same thing instead of building your own. Or you may have some apps that can simply retire and you don't need to consider them to be migrated. So all in all, these are the different options or strategies to help you to migrate over the apps into the new platform. As we mentioned earlier, one of the key challenges the enterprise will face is having a hard time to estimate the efforts needed to migrate the applications. Indeed, the efforts needed to migrate would probably depend on the technology that these apps are used to build. So in this slide, we are trying to give you a guidance on the efforts needed based on different types of technology the app is using. Let's take a look at the Java and .NET programming language and its framework, which are the most prevailing language used in enterprise software development. In the Java world, the more self-contained, like the FatJar with the embedded servlet engine running in it, prepackaged, the more stateless the application is, the more trivial the effort is needed. This is a general thinking. And it's almost like lift and shift, just containerize them, and then you can simply put it to the Kubernetes platform that you run, and that's it. However, if the application has more tight coupling with its underlying operating system or the hardware that it's running on, or it involves features like transactional support in ESB, for example, this would not be trivial, or it will take certain amount of effort in the migration process. So this hopefully can be a good guideline for you in estimating the effort needed for migrating the Java applications. So what about .NET? Likewise, in the .NET world, it's trivial to migrate the .NET Core-based framework, such as ASP.NET 5 application, ASP.NET MVC applications that are built on the .NET Core runtime. But for those that are not .NET Core but .NET Framework based, they are more relying on the Windows-specific kernel and architecture to run. So that will be harder or almost impossible right now, or we are pushing the limit to migrate them, to try to migrate them over to the SUSE Container Application Platform. Let's take a look at moving workloads into SUSE Container Application Platform. Generally speaking, there are two types of workloads, stateful and stateless. Stateful is like the shopping cart. The app requires somewhere to store the items to be purchased and processed. So another workload type is stateless. It's just like a static website. You don't need to identify or personalize each visitor to process the website to give the response to them. Every request will respond the same kind of information. That is the stateless. That is the example of stateless workload. Most of the workloads, whether they are stateful or stateless, are migratable to SUSE Container and Application Platform because this platform contains Kubernetes and Cloud Foundry together. But for some people, they may wonder how should they pick the right way to move their workloads into it. I would say in general, if the software is self-developed and you have the source code of it, I would suggest you start with migrating it with the Cloud Foundry way to begin with, especially if you want to focus more on the application functionality rather than handling the underlying infrastructure, how it should be deployed. That would be the good way to do. Indeed, a lot of startup and web-based application are using this Cloud Foundry way to handle it in the cloud. And what about Kubernetes? Well, if you have the stateful workloads like distributed database or the data analytics components or a cluster, MySQL cluster, Kafka cluster, then these stateful workloads, you can leverage the Kubernetes constructs like operator, like the stateful sets to help you to manage all these stateful workloads in the Kubernetes in a much better way. Another scenario is like if you have the commercial package that provides you the Helm chart to deploy onto a cloud native platform like Kubernetes, then this is the supported way to go into the Kubernetes. SAP Data Hub is a good example of it. Now you may wonder how a three-tier architecture application running in VM is different from running in Kubernetes like CaaS. Basically, as you can see in these diagrams, they can be very similar, but it's just that the objects need to manage each part of the architecture is different. For example, you used it to host your application in the VM, but now when it's containerized, it will be using pod. Likewise, to direct the traffic, in the VM, you use the load balancer, but in Kubernetes, you use service and ingress to do it. So let's take a deeper look at how this app hosting environment look like in Kubernetes or CaaS. Now, assuming this is the environment, we have the Kubernetes cluster or CaaS cluster. And then to start with, we define a namespace to logically group the applications in the Kubernetes cluster and set the limits for the CPU and memory capacity usage by the applications running within this namespace. And then the application, like Java application, is containerized and deployed as a pod, which is governed by the deployment and replica set to ensure the resilience and scalability, and also support the various application upgrade strategies using these resources in Kubernetes. And then the app will also be decoupled with the underlying storage through the use of persistent volume, storage class, or persistent volume claim concepts. All the data accessible by the application will be stored in the mounted volume defined by the developers and administrators. And then all the configurations are externalized and stored in the either config set or the secrets. So these are the facilities that can help to build the 12-factor app. And lastly, if the user needs to access to the application, so the service can be exposed through the service object, and then the traffic can be controlled through the ingress controller. So the users can, through some domain name, to access to the application through these resources as well. So this is the typical environment that you can see in the Kubernetes when the app is hosting in it. Now, With this basic understanding of how the application is being hosted in the Kubernetes, um, let's take a look at the um, migration guideline for the application moving into this SUSE CaaS or Kubernetes platform. The very first thing, of course, is to refer to the 12-factor app to make your application as stateless as possible, as and also as disposable as possible. Try to decompose it to decouple for any dependency and also all the backend services. And then the second thing that need to do is to follow the best practices in containerization. For example, you choose some secure and small base image to start with and follow some best practice guideline as I highlighted here in the hyperlink for your reference. And then just like the previous slide, try to make best use of the Kubernetes resources objects to manage your applications. This includes the config map, externalize your configuration, or maybe you put some secrets credentials into the secrets objects, or you may also want to integrate it with the third-party vault for better security. Resilience is provided by the replica set using the deployment resources, expose the services, and so on. So all of this must be followed. Another important point to consider is high observability. Logs and basic metrics are not enough to achieve the observability of your containers and microservices running in SUSE CaaS platform. For faster recovery and higher resilience, applications must be highly observable. So this requires the application migrated to Kubernetes have proper logging, detailed monitoring, health probes, and performance or logical tracing. Last but not the least, if you want to secure the port-to-port communication, just like the firewalls in the virtualized environment, you may also want to implement the network policy along with your applications. Hope this guideline will help you to migrate successfully your workloads into the SUSE container application platform. Now, I'm going to do some demonstration about migrating a Java application that I picked up from the internet, from GitHub. The demo does not require any code change to the Java app to make it as simple as possible. And I'm going to illustrate how to deploy this Java application from the source code into the SUSE CaaS platform. And at the same time, show you for the same application how it can be deployed to the SUSE Cloud Application Platform. The Java application that I've picked up is called Spring Pet Clinic. This sample application has a long history in the Java community and is one of the showcase Java application that people usually will port over or try to derive the same application with different framework to implement. So if you look at the website that I've gave it to you, then you can really go deeper into a look at this Java application. Let's take a look at the overall plan on how we migrate it. So this is the diagram showing you how we deploy the Java app using two different approach. One is the Kubernetes way and the other one is the Cloud Foundry way. No matter which way that you do, they will be landed to the same platform running on Kubernetes. So let's dive in to take a look at how this demo works. In this demo, what I'm going to do is I'm going to migrate a Spring-based Java application into SUSE CaaS platform. To do that, here I'm now in the /15 SP1 Linux machine. I have a few files with me to accelerate this demo. So first thing that we need to do is to build a /15 based OpenJDK image. So I have already prepared a Docker file for it. Let's take a look at its content. JDK. Now you can see that this is based on /15, and then I'm going to build it, and that's why I need to update the CA certificate from its Docker host file and add all the uh, repo that I need into this container before I start installing the um, OpenJDK package into this container. So this is basically the Docker file that I have. And if you look at how I build it, you can see that I will run this Docker building process in the /15 host. And then you will see that also I need to copy the relevant Cyper repositories and services files into this container before I start building it. Now let's take a look at my existing Docker images. So far I don't have any OpenJDK build. Let's run this build command to build it. So let me run this script and it will help me to automatically build the OpenJDK file for me. So it may take a while. Cool. Looks like the /15 based OpenJDK is now available. Let me double check my local container image list. Yes, it is there. And now let me tag this into a specific version, and then I will upload it to the Docker Hub with my own account, Suse samples, in this demo. And then I will be using this specific version to deploy my Java application. So now I'm able to log in to my Docker Hub account. So I've already logged in, and so I can simply push it now. Okay, looks like the Docker Hub has already got my latest OpenJDK image, which is based on /15 SP1. And now let me build the Pet Clinic app. So again, I've already prepared the Docker file for this app. And let's open it up and take a look. This file illustrates how the multi-stage Docker build it is. So first, it uses the Maven builder, and then it will use the Maven command to build the Java project, Pet Clinic project, and using the Maven package command to build it. And once the package is there, it will be outputting it as a jar file. And then in the second part of the stage, in the later stage, we build the Docker image based on the OpenJDK as a runtime. And then we simply put in the jar file as the application that we are going to run. And then this is the most basic and easy way to containerize our Pet Clinic Java application. So let's give it a try and see how it goes. Now, let me double check again. Right now, I only have this /15 OpenJDK 11 image. Now let's take a look at the script to build it in this demo, to build this Docker file. So basically what you will be doing is it will clone the source code of the Pet Clinic, the Java application, and then copy the Docker file that you have just seen into that source code directory. And then we will get into that directory and run that Docker build command to build the Pet Clinic Docker image and give a version of it. So let's take a look at what this source code is about. I'm going to open it up. So as you can see, this is the source code of the Spring-based Java application. And once we run it, we should be able to see this database, a web-based database application. Let's take a look back here. Let's try to run this script and build the Docker image for this pet clinic. So I simply run this command. And now you will download the source code from the GitHub and start building the image now. Cool, I've already got there. If I look at the Docker images, you should be able to see this image is built. That's good. And then now let's push it to the Docker Hub and store this image in the public container registry that I have. Let's push it there. Okay, it's done. Let me go to the Docker Hub and check if the pet clinic image is there. So I open up and then I go to the Docker Hub. So as you can see here, this is the OpenJDK image that we just built previously. And then a moment ago, we also built this pet clinic, and you can see it's available now. So what's next now? Now, let's deploy it to the CaaS cluster, SUSE CaaS cluster. In my environment, in this environment, I've already set up my kubectl kubectl command line to connect to my own CaaS cluster. So if I run this kubectl get note and then give me more information, you'll be able to see that I'm connecting to a small cluster running with Kubernetes version 1.17. Okay, so now what I'm going to do is to put the pet clinic Docker image into this CaaS cluster. Maybe you may have seen somewhere before that most people need to write the manifest, the Kubernetes manifest, in order to deploy the Docker image properly into the CaaS, in order to deploy the Docker image into Kubernetes properly. But today in this demo, what I'm going to show you is simply to use command line to deploy it. Of course, I will also show you how you can capture this command line, convert them into the manifest that you need so that you can modify from there instead of starting everything from scratch. So let's do it now. First, what I would like to do is I want to create my own application namespace to run this application. So first thing that I would do is I will use kubectl to create namespace, SUSECON. And if I look at it now, NS for namespace, then you will see this is the SUSECON namespace. I'm going to put my application over there. And I want to make sure I will always use this SUSECON namespace as a default namespace in the current context now. So let me set it up quickly. Okay. So what's next is I want to store my Docker credential as a secret inside this SUSECON namespace. So my Docker credential, the Docker Hub credential, if I log in again, it will indicate that it's stored in this directory as in this file. So what I need to do now is to create a Kubernetes secret to put this file as part of the secret. So to do that, I have already set up a command to do it. Let me just copy and paste to here. And so this is the command to do it. Basically, is to create a secret with docker cred, the name, and the content is loaded from this file under this namespace, and this is the docker config JSON file. So let's create it now. Now it's created, and then we want to associate this docker credential secret as part of our default service account in the SUSECON namespace, so that when we need to pull images within this namespace, then I don't need to specify the credential for me. It will fetch it from this service account automatically. So the command to do it is like this. And now I just double check SA for service account, and then you can always retrieve the description like this. Now when I double check it, I can see that the image pool secret property has been set up to refer to the secret named docker cred. That's good. So I don't need to specify my credential every time when I fetch images from my own Docker Hub registry. So what's next is to start deploying the pet clinic into my cluster. So how can I do that? If you're using command line, you can always do it like this. Let me copy the command to here, kill it. So it looks like the deployment is done. I can check the deployment. Now one is available. It looks like it's deployed. So I can also double check the pods. The pods is running. Looks like my image is running. I can see it's coming from the image that I built. It's hosted in the Docker Hub. So now the next thing that I will do is to expose this pet clinic app to be accessible with the Notepod service. To do that, I use another command to do it. It's just to expose the deployment with a Notepod here, like this. So it's under SUSECON namespace for this deployment named the pet clinic, and then I want to expose it as a service to be consumed through the Notepod mechanism with port 8080 as a target port. So I simply run it, and then if I check the service, then you will see that there's a pet clinic service called Notepod exposed, mapping to the port 8080, and the external port is a high port called 30174. So how can I access to this service? What I would do is to find out one of the IP address of my worker nodes. Take a look at the IP address here. Maybe I just use the 38. So the app would be accessible from this IP and the port number. Here we go. We got the pet clinic deployed in here. So this is a list of data. I can access to it quite easily. All right. Now, next thing that we're going to do is to deploy the same application into SUSE CAP, SUSE Cloud Application Platform, which is a containerized cloud foundry running on top of Kubernetes. So we will deploy the application using the cloud foundry way. So one thing that I would do is I log into my sandbox account. I'm going to use the command line to do the login. So I simply log into here. I enter my own username, and then enter my password. And I've already created a SUSECON space. So I choose the SUSECON space. But if you haven't done it, then you can, after login, you can always do it like this. CF and then create space SUSECON. Then it will help you to create that space if it's not existing yet. And then we switch to that space. The space is like the namespace in Kubernetes, or is a working space for hosting your application. So I now change it to set the default as the space SUSECON. What's next is what I will be doing is I take a look at the working folder, and then I switch to this pet clinic source code folder. So, and then I start run the Maven command to build the jar file for this Java application. So the Maven command that I will be using is running from a container. So I will run this command, docker run, and then using the Maven image that I have in my local Docker, and then I just point to my application, map it into the container, and try to build it. So this is a standard official Maven Docker image. So I just follow its instruction to run this. So now I just trigger the Maven, and then it will build the packaged jar file that I need and put it into the output folder. So it may take a while. Now the build is successful. So let me check if the jar file exists. It should be under target directory. Here we go. I just got this file built. Now I run the CF push to push this jar file into Cloud Foundry. CF push and then pet clinic -p and then target spring pet clinic, like this, the whole jar file. So what it will be doing is it will push this jar file application into my SUSE Cloud application platform. It will upload it, and then the SUSE Cloud application platform will identify what kind of source is it. So it will detect which build pack that it will be using. In this case, it will be picking up the right one, which is called Java build pack. So the Java build pack will simply try to package the jar into a container called droplet, and then it will be managed by the Dago scheduler and put it into the right Dago cell under Kubernetes that I have. So right now it's building it, and it's already identified that it's placed into the stage area, Dago cell, and we are waiting for the application start. So it may take a while, but it's fully automated. We don't need the developer to know how to containerize it, write the Docker file that they need to have, choose the right image, the base image to start with. It eliminates all this pumping work for the developers so that they can free up their time to focus more on the quality and the innovation that they need to have for the software that they develop. So now the application looks like it's running. I can double check here, CF apps, and then you can see that, oh, my application pet clinic is now available. So this is the URL to host this file. Again, when I deploy it, I don't need to be like in the CaaS environment. I need to expose to a certain port number, and it even did not have the handy URL for me. But for SUSECAP, it's already automatically create a route that I need to access to my application easily. Again, if I'm a developer who are not familiar with the networking side, how it works, then this is really handy for them to focus on what they're good at. So let me try to load if this application is running. Cool, now it's running on the SUSECON environment. It's the same app, but you can see the number of steps that I need to take is much more smaller. But of course, I may not have more fine-grained control on how the underlying infrastructure would look like. But that's the beauty of CaaS, right? It abstracts the underlying infrastructure from developers so that they can focus more on developing instead of taking care of the infrastructure as well. But for CaaS platform, it also empower the developer to take control if they need to on the infrastructure side. So that's why the SUSE container and application platform include both technology to offer the flexibility to different types of organization or different types of developers to fulfill their needs. So that's all for the demo. Let's recap on what we learned from this demo. So first thing is it's a good practice to use the multi-stage Docker build to containerize your application. This will make every time you change the code, make it faster and easier to rebuild the containers. If you need further instruction or how to refer, if you need further reference to it, I've put it at the end of this presentation, a link over there. The other thing that we learned is that the application deployment into Kubernetes can be in an imperative way, meaning using the command line if your instruction is relatively simple. But if you want to have a more customized option, then you can write your own manifest using the YAML file format to write down all your deployment instructions in a more declarative way. Thirdly, the SUSE Cloud Application Platform, as you can see, compare with the SUSE CaaS deployment approach, it simplifies and standardizes your application deployment for developers, make them more focused on their application feature development instead of learning how the containerization work, or ask them to take care of the base image that they need to have, as you can see in the demo. And then Stratus, as you can see at the end of the demo, can also help to simplify the operators to govern and manage those cloud-native applications deployed. If you're interested to follow this demo, I've also put up all the scripts that I have written in a GitHub, as you can see in this link. Check it out if you're interested to do it on your own. After you migrated the applications onto the SUSE Container Application Platform, you may also want to check out some other interesting aspects to improve your cloud nativeness of your application. For example, you may want to look into the tools that can help you to monitor what's going on with your application and the container platform, like using Prometheus or Grafana. Or you may want to consider your application to adopt the microservices, leveraging the service mesh. So in the Kubernetes world, we have the Istio and also the Envoy project that can help you to make microservices secure and easier to manage through the service mesh concept. And likewise, for security concern port-to-port communication, you can also leverage the Cilium, which is one of the CNI container networking interface projects that the SUSE CaaS platform has adopted. So Cilium can let you define the network policy to govern the port-to-port communication. And If you're interested to look into the observability of your network, you may also want to look into the Project Hubble as well. If you're developing the API service, then you may also want to consider using the gRPC, which is in general much more performant than the JSON-based API. So security aspect is quite a large aspect that you may also want to learn and look into to secure your containers running on the Kubernetes. These are the post-migration activities that I think you may also want to check and continuously improve the scalability and reliability and security of your application running in this cloud-native platform. So before I end this session, let me give you a free gift. You may want to try out the SUSE Cloud Application Platform for free. And here's the link that you can sign up and try to follow the demo script that I just mentioned earlier and run the application, Java application right away in this free account. I would love to hear your feedback after you try it out. Just feel free to reach out to me. So here are the other reading that you may find it interesting and is relevant to the talk today. Feel free to look it up. And that's all for today's session. I guess if you have any questions, please feel free to leave your questions below or feel free to contact me through the SUSECON Digital platform. With that, stay safe, happy, and healthy. Until next time, see you. Bye.